Morning. Mr. Lesham here. We're carrying on with finding the general solution for a trig equation. That's probably like the biggest thing we're learning this year in trig. So it's going to take us a couple of lessons. We've dealt with sine and cosine, okay? And we saw the general solution. Now we're going to extend it to tan. And you see there's going to be a little bit of a difference. It's going to be a little bit of a difference. So I chose a negative number here just to get us practicing this whole business of reference angle. It starts very much the same, okay? If I want to know the reference angle, is going to be what?
1. Inverse.
The inverse of tan now of 1. You're right. Okay, we're not gonna include that minus sign. The reference angle we always use the positive value. Okay, because the reference angle forever lives in the first quadrant where all tan, sine, cosine, they're all positive. So tan of 1, or this is a special angle. Anyone remember what's
45?
45. Nice. Okay. So 45 will give you a tan 1. Tan 45 is 1. Tan 45 is 1. That means the tan inverse tan of 1 is 45. So that's the reference angle. Now we got to say, okay, but really, I'm looking for angles that their tan will be minus 1. So I'm looking for 2 quadrants. Where will my quadrant live? Second and fourth. You're on fire today, okay? Because these are quadrants where tan is negative. So my first one is going to be 180 minus reference angle, which is 135. That's one angle in the second quadrant. The second one will be 360 minus 45, which is 315. So these are my 2 angles between 0 to 360. That'll give us tan minus 1. I'll just pause here to make sure you've got it. So far, everything is pretty much the same, and then we're going to carry on with the same. We're going to write the general solution, because we know these are the 2 solutions, I will use that word, in the interval. Interval is a mathematical word. In the interval between 0 to 360. It's an interval between 0 and 360. But we know we have infinite more solutions, and we know how to construct it. Okay? We're going to use 135, and what are we going to add to it?
360. Oh, K times.
K times 360. Or we can say theta is equal to 315 plus K times 360. And I need to specify that K belongs to Z. It's a natural, not a natural number, so it's an integer. 0, 1, 2, 3, or minus 1, minus 2, minus 3, and so on. Okay, now, if you write that in a test, you will just lose 1 mark. Okay, so even if you're not going to get what I'm going to say now, it's not the end of the world, you're just losing 1 mark. But what I'm going to say now is not too difficult, so don't worry about it. Okay? Let's start writing our answers. Okay? So we're going to write down the answers. Okay, so here I'm going to write these ones, and here I'm going to write that one. These ones. Okay, so the first one is 135. What will be the next one? Can you use some bigs? You have a man.
495.
Okay, 495. Okay? Let's do one more.
855.
855? You sure? We're adding 365. Is that 855?
He's dead, sure. He has a calculator.
Okay, good. There's nothing wrong with calculator. Okay, so these are the first 3 of this one. Obviously, I didn't include the minus. I could put K minus, but never mind that. Now, let's write these one. Alright, so 315 is the first one. What's the next one?
1200.
No, hang on. We add 360 to that. That should be easy. That's 675, right? Yeah? Okay. Now I want you to try something. Well, I'll just leave you for a second here. Let's see if we notice something about these numbers. I'll just pause here, see if you notice. What you guys notice very nicely, okay? That there is a certain relationship between these 2 numbers. If I'm adding 180 to 135, I get 315. Yeah, that's true. If I'm adding 180 to 315, do I get that? I do get that. Yeah. And if I'm adding 180, it goes on like this. Okay? In other words, I don't need to have both of these rules. Until now, for sine and cosine, I have to write two lines for the general solution. Either that plus 360k or that plus 360k. I can swap this whole thing with one line. Okay? Okay, I can swap that. This is equivalent to say theta is equal to. And I just want to give you a chance, see if you can figure it out. Well done, okay? So those two lines can be written as 135 plus k times 180. Where k, obviously, I'll write it down in a different color, k belongs to z. Okay? So, and it only works for tan and cotan, but so far we haven't come across cotan. Okay? Those two lines should be reduced to this one line using just one of these answers, and instead of adding 360k, we're using 180k. Okay? With that, you can construct all of those. Okay? And we must do that. Okay? I'll pause again.
That's amazing.
Right, so a couple complications that we can come across. One of them I think you already figured out by yourself. If you've got an equation like that, okay, we want to turn it into tan theta equals something. And that can be done very easily, right? 3 tan theta equals 4. And then tan theta equals 4 over 3. Yeah, you figure it out by yourself, right? And then we move on. I'm not going to even do that. It's the same procedure. Again, whenever you have tan, your answers are always going to be 180k eventually. Okay? This one I didn't ask you to do. Okay? Let's just, we're not going to solve the whole thing. Let's just get it into like a normal way. So what do you reckon I should do here? I wanna find, eventually get sine theta equals something.
So 1/8 across.
Great. So we're going to write sine theta over 6 equal 1 over 8.
And you take the times 6 on both sides.
Fantastic. So we're going to write sine theta equals 6 over 8, which we can obviously straight away write as sine theta equals 3 over 4. Let's see if you're happy with that. You happy with that? So now, yeah, we're getting to, like you said, the core of it, the hard bit. Okay? So I've got, until now, I always have sine theta equal to something. Now I've got sine 2 theta equals something. And I can tell you guys that is confusing and it can easily make a mistake. So let's just follow the procedure as best as we can. We start the same thing. Okay? Now, by the way, I'm going to put brackets here. Normally, you're not going to have these brackets. You need to understand when it says not sine 2 theta, it means that the angle, sine always is something that works on an angle. Your angle now is 2 theta. Okay? So we start the same thing. The reference angle equal to what?
Inverse operation.
Inverse of a quarter. Okay? Let's get an answer for that. For now, I dish the 2 theta, as I always do. Okay? I'm finding the reference angle. What do we get? 2 decimals.
14,48.
14,48. It's in my first quadrant. Fantastic. Okay. Here comes the trick. Okay? Before, when I had, let's say, I'll write down, let's say I had sine theta equal a quarter. So I've done the same thing, but instead of 2 theta, let's say it was sine theta. I would find out that the reference angle is 14,48. What will be my first angle in the first quadrant? Just the reference angle, which is 14,48, right? If I'm solving this problem, yeah?
Yes, sir.
And then the next answer would have been,
Divide by 2.
where is sine? Sine is in the second quadrant. Sine is positive in the second quadrant, so it will be 180 minus 14,48. Okay? What is the difference here? Is now I have 2 theta. So what what do I have to write?
Divide by 2.
Before you divide by 2, what do we write?
2 theta.
Yes, exactly. So we're going to say 2 theta is equal to the reference angle, which is 14,48, which means theta is equal to 7,24. That's the first angle. But we've got another option. 2 theta, I'll call it 2 theta 2, just to show we have 2 solutions. What is that second option? 2 theta equal 180 minus the reference angle. Reference angle. which we already figure out here. We didn't figure out. What is it? Whether 180 minus 5%? Okay, so we're going to write it 2 theta 2 is equal to 165, 52. Okay? And that means that theta 2 is equal to half of that, right? How much? 82,76. So now I've got two answers in the interval between 0 to 360. I need to make the general solution.
So what do you do with the ones with no brackets?
With the what? Sorry? No, that was a different question.
Oh, okay.
I just want to compare that to the question we asked here. Okay? So now we're going to write two answers. The first answer is 7,24 plus...
180k.
No, 180 is only for tan. This is a sign. K times 360. And we always start with K times 360. It's only that when it gets to tan, we can combine into 180. Or, so that's one answer, or, what's the other option? Theta equal to 82,76 plus K times 360 with K belong to Z. That is my final answer. Okay? I'll answer the question in a second, but I just want to note here that the only thing we did is we just had to divide it by 2. Okay, we took our first answer, we divide by 2. We took the second answer, which lives in the second quadrant, we divided by 2. That's all we did. But you will see in the next place, it's going to be even a little bit more complicated. It's important that you keep that procedure the same. So first we find the reference angle, then we make the whatever is in here equal to the reference angle or to 180 minus the reference angle, and then we try and find out these two. I'll pause for questions. Okay. Last bit, and definitely the most difficult question, but it is something we can do if we just stick to the procedure. Okay? So first of all, I want to have tan, that should be a theta here, tan of this equal to something. How do I get rid of the 2? Divide by 2. So tan 2 theta minus 10 equal 2. Okay? Now it's nice and normal. Now next thing I want to calculate, the reference angle, right? I'll write that in black. Yes, there's a question. So there was a question here, can we take the 10 out there? If there were no brackets, if this was no brackets here, that means what I really have is tan 2 theta minus 10 equal 2. Then you're right. Then what we should do is tan 2 theta equal 12. You're absolutely right. But, and then, there could be questions like that, okay? But if there are brackets here, as you got in the original question, you've got brackets here, that means that the angle that you're doing tan on is this 2 theta minus 10. Then you can't do plus 10. Okay? We need to move on and find the reference angle. Was there another question?
So I was going to ask, can't you find the inverse
Yes, you can.
term?
A good question. Okay, so the reference angle should be reference angle, not angle reference. Is going to be tan minus 1 of 2, right? 63.43. Fantastic. Okay, now I've got a positive here, so which quadrant am I looking for answers?
Third quadrant.
First and third. Okay? So now I gotta say something is equal to 63,43. What is this something? It's not theta.
2 theta minus 10.
Let's do it in blue. Okay? So we're going to say, okay, the reference angle, 63,43, is equal to whatever angle tan is working on, which is 2 theta minus 10.
Oh.
Let's pause here. This is just half of the solution. The other half of the solution would be 2 theta minus 10 equal, not to 63, but to, where was the other quadrant that we have an answer? 180 minus, plus, you're right. 180 plus 63,43, or let's write it down straight away. 2 theta equal to, 2 theta minus 10 equal
243,43.
Fantastic. Okay? So these are going to give birth to all my solutions. Okay. Right. Now we solve it like we solve any algebra. What will be the first step to do?
253,4.
No, let's work with this one first of all.
Plus 10, sorry.
Plus 10.
Plus 10. Now I'm plussing the two. Okay? So 2 theta equal to 73,43. And now I'm dividing by 2. Theta equal to?
36.
Hang on. I just realized I made a mistake. I realized I made a mistake. I need to correct a few things. Before I go over to the way we should do it, let me show you why I got it wrong. It's going to be hard to explain why I got it wrong. So, what am I missing here from the 60? Okay, 63,43 is one answer.
Plus 360.
Exactly. Okay? So what am I missing? I'm going to rewrite it to give us some more space. Okay? Okay? What we got to write now, still write in blue, is that 2 theta minus 10 should be equal to 63,43 plus k times 360 to find the general solution. Because what we're looking for is to find the general solution. Now, I'm actually, just for the hell of it, I'm going to write down the way I wrote it. What did I write? 2 theta minus 10 equals 63,43. And I want to show you why, if I carried on, it would be wrong. You'll see in a second. Okay, let me answer your question in a minute. Okay? Now let's solve that. Okay, let's solve that. Okay, so now we're going to add 10 as we added before. 73,43 plus k times 360. Divide by 2. Need your calculator here, guys. 73 over 43. 73,43. 30 something.
36,72.
72.
Yeah.
Plus what?
360.
K times 180.
Okay, we divide that by 2, we're going to get k times 180.
Oh.
So now it goes in 180, kind of like the tan. Okay, now let's compare what would happen if we carried on. Okay, I'm going to write it here so we'll have more space. Okay, originally I wrote it like this.
You just get dt equals
Okay.
36.
Let's see what we will get. We would have got the same. We'll get We'll get 36,72. Okay, that's what would have happened. And then what would I do to get the general solution? What would I say?
K multiplied.
36,72 plus what?
Plus K multiplied 360.
K times 360. But it should be, if I did it right, and I did it right here, it should be 180. So what do we have to learn from that? Is that we got to keep this angle 2 theta minus 10. Keep it there, don't move anything until I write the general solution, including that 360 times k. Okay? It's tricky. Okay? Let's do the same thing here. Okay? So we have one class of answers, but that's not all of it. Okay? I also need to deal with that answer in the third quadrant, which we said at 243,43. Should I move the 10 now?
Yes, sir.
No. What did I need to write still? Plus?
360K.
K times 360. So now I'm going to write that down here. So I'm going to say 2 theta equal 253,43. I'm just adding 10 plus k times 360. And then theta equal, need your help on this one?
Yes, I don't know.
Divide by 2,
126,72.
72 plus k times
180.
180. And these are both our solution. We need to specify both of them. Either that or that. Okay? I'll pause here. I think this is it for today. I'll say goodbye. Oh, hang on, there's a problem. Okay, well done guys. You notice that I must write it's either that or that, but I also must say that k belongs to 0. Absolutely right. Okay, cheerios, bye-bye. Thank you here for Simon for reminding me that in a tan, okay, when we come to tan, we already have 180. So we have a period of 180. So what we need to notice here, an extra little bit, is that these two lines can be combined. I don't know if you can see it here. They can be combined to 36,72 plus 90k. I mean, check this out. 36,72 plus 90 will bring you to the 126. So a tan, okay, when I have 2 in front of it, will actually go down to 90k. Now, as I already told you, I know I'm repeating it for the camera now, I strongly suggest that you do it from the beginning. So I'm just going to put that here. Sorry, thank you, so. Okay, so what I really suggest is when you've got these two reference angles equals 63 and 243 plus 1 for 360k, combine them as we combined them before for the tan, combine them to 63,43 plus k 80, and then solve for theta. You will get the same answer, but there's more chance you'll get it right then. Don't worry, we're going to need to practice it a lot next lesson. Bye-bye.